Hi, Year 11. This is our fourth lesson of our waves physics topics, and thanks so much for keeping up with this. It isn't too late to go back and catch up on lessons 1, 2, and 3 if you want to, but this is the fourth one, and it follows on from yesterday's lesson all about the electromagnetic spectrum. No writing to be done in today's lesson. You're going to be all working on the worksheet today, but you will find a calculator useful for the last task we do at the end of the lesson. But you can always use the calculator on your phone, or you can use the calculator on your laptop. So don't worry about running off and getting one. You can always pause me as well if you want to. Okay, so let me get on with sharing my screen. And I shall get our lesson ready to go. Here we go. So today we're going to be looking at the different electromagnetic waves, but how we use them. We've developed loads and loads of bits of technology and kit which use all these different electromagnetic waves. So the two things that you've got with this lesson, you have got a fact sheet. So you can open that up. That's one of the documents that comes with the lessons. That fact sheet is a Word document which has loads and loads of information about how we use the different sorts of electromagnetic waves, and it's broken down into the 7 sections of the types of electromagnetic wave we learned about: radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. So that's the fact sheet, and you've also got a worksheet that goes with the lesson. And the worksheet, it's 2 slides which you're going to be filling in these different boxes here. It's 2 slides. The first one looks like a big table, and the second one has a picture of a banana on it. So if you've got those 2 documents attached to the lesson, let me show you how we're going to be doing our work today. A lot of the stuff we're doing today is really over to you to do a bunch of research about how we use the different sorts of electromagnetic wave. And for each wave, if we look on our worksheet, we're going to need to find out how we use it, any dangers that might come from that sort of wave. Is this type of wave ionizing, whatever that means, although you might recognize the word ion from your chemistry lessons, and any other information about this sort of wave. So let's see how we can fill out this research sheet. We're going to go through the waves in order. You can see that the waves are listed down the side of the table. And what I'm going to ask you to do is fill in one row at a time on your table. So let me show you how I would fill in the information about radio waves. Okay, so let's have a look. I can see the first part of my sheet is where I'm going to list the uses. So anything that people use radio waves for. So I would go to my fact sheet, go to my radio wave section, and I would find any ways that the wave is used. So if I look through this information here, I can skim through that and find any ways that radio waves are used. As I go through it, I can see radio waves are used for Freeview television signals. They're used for radio signals. They are used for communications. So all those are different ways that radio waves are used. So I can go to my worksheet and I can fill in that information about how they're used. Radio waves are used for Freeview TV, radio signals, and communication. So that would fit very nicely in here. So I can put Freeview TV, Freeview TV, excuse my handwriting. We've got radio signals, like listening to the radio, and we've got communications. What am I going to fit this in? Communications. Oh, it's going to go into the next box. You can type yours in much better. Okay, so that's that one filled in. What have we got then? So that is the uses of radio waves filled in. What's the next section? The next section is dangers. I want you to find any dangers. So I want you to skim through this and find if they are dangerous. Now, some of these waves are really dangerous, some of them not so much. So I have put a note there saying there may be no dangers from some of these waves. And actually, as I skim through these, I can actually see it says there that radio waves do not cause any damage in the human body. So there aren't really any dangers of radio waves. So I could go to my sheet and I could write that, let's have a look, radio waves do not cause any damage. So dangers. Do not cause any damage. Do not cause damage. Do not cause damage. Good stuff. Alrighty, what's my next section I need to fill in? Next section there was the two last boxes really. Number one, are these waves ionizing? Now, it's going to be a yes or a no answer to this. We'll tell you a little bit more about what ionizing means later in the lesson, but really it's going to be a yes or a no. I need to scan through this and see if they are ionizing. If it says they're ionizing, I can write yes. If it doesn't say it, I can write no. So if I skim through this, looking for anywhere where it says if radio waves are ionizing, nothing there. So it's not an ionizing type of wave. And any other information, I could really pick anything I wanted to from there. Reading about radio waves there, I can see what's of they can be reflected to change their direction. They can travel easily through the air. So that's the sort of information I can put in the other information box. So let's have a look. I can go back to my table. And is it ionizing? Nope, nothing in that fact sheet said it was ionizing. Other information, they can be reflected. So I can fit that in. They can be reflected. And they travel easily through the air. You can type this much neater than me. Travel easily through the air. We'll just about squeeze that in. So you can see how I filled in all the information about radio waves by using my fact sheet. So really, it's up to you now. You need to go through the other types of wave, all these different types of wave, radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays, all the different types of wave. And at each part of the fact sheet, you need to check out, find that information, find its uses, find its dangers. You need to find out if it's ionizing and put anything else that's interesting about that wave into your table there. So you'll have that whole table filled in. You can type the information into the worksheet and you'll have the information about all 7 different sorts of wave. So what I'd suggest you do now, pause the video. And take as long as you need. It's a decent research task, that. So give yourself as long as you need to fill in all the rows on that table. So you can pause the video now, and then once you've filled in the table using the fact sheet, start the video up again. So pause me now. Welcome back. Thanks for filling in the table there. And I want to talk a bit more about what ionizing means. For each of the types of waves, I asked you to find out if they were ionizing. And if you've done your research right, you'll have noticed that the types of waves that are ionizing are ultraviolet, X-rays, and gamma rays. What does ionizing mean? Well, ionizing, just like in your chemistry, means that those waves have enough energy to knock electrons, bam, off atoms. Now, if that happens to your DNA in your cells, if your DNA gets ionized, that can lead to cancer. So that's why we're more cautious about those types of wave. They can be more dangerous. So those ionizing types of radiation can be dangerous. So to check how much electromagnetic ionizing waves we're being exposed to, we can measure how much danger we're in by measuring the amount of electromagnetic radiation in a unit called sieverts, S-I-E-V-E-R-T-S. So for example, you might measure a dose as 5 microsieverts or milli. Why do we use such micro and milli? Well, it's because 1 sievert of electromagnetic waves would actually be a really, really big dangerous dose. So we normally measure the amount of radiation in smaller units, like millisieverts, which is 1,000th of a sievert, or microsieverts, even smaller. That's 1,000,000th of a sievert. So when we're looking at the dose we are exposed to, we would use these sieverts if it's a very big dose, but you're more likely to see millisieverts, that's 1,000th, or microsieverts, that's 1,000,000th of a sievert. So for example, if we look at some of these different X-rays you might get in hospital, these are some of the doses you might get in microsieverts. Now, a microsievert, remember, is a millionth of a sievert. So although those numbers might seem scary, it takes a really, really big dose to even slightly increase your risk of cancer. It takes about 100,000 microsieverts to even start increasing the chances of anything going wrong. So even getting a dental x-ray is only 5 microsieverts, and it would take 100,000 microsieverts to even start increasing your risk. So let's have a think. How many dental x-rays would actually take to increase your risk? Well, let's have a look. A dental x-ray gives you a dose of 5 microsieverts. Now, the lowest dose that can cause you any problems is 100,000 sieverts. A dental x-ray is 5 microsieverts. So how many of those would I need to get 100,000? So I take 100,000, divide it by the 5 microsieverts, and that tells me I would need 20,000 x-rays from the dentist to even slightly increase my chance of becoming sick or developing a cancer. So it's a ridiculously big number. So although some of those radiation doses you might think are scary numbers, actually they're such tiny numbers that it hardly makes any difference. So what I want you to do is have a look at some other ways you could get exposed to ionizing radiation. And I want you to try and figure out how dangerous they are. How many of these different things would it take to reach 100,000 microsieverts? And this is the second page of your worksheet. So if we look at the second page of the worksheet, after the table we filled in, I want you to look at how many of each of these it takes to reach 100,000 microsieverts. So all you're going to be doing is dividing the 100,000, which is the target we're sort of trying to reach, by the number of microsieverts in whatever is happening. So for example, flying from Manchester to New York, on average, gives us a radiation or an electromagnetic ionizing dose of about 40 microsieverts. So how many times will I have to fly from Manchester to New York to increase my health risk? Well, I need to say it takes 100,000 to increase my health risk. Divide by the 40. And if I bash that into my calculator, that would take me 2,500 trips from Manchester to New York to increase my health risk. So you're dividing 100,000 by the number of microsieverts. So I want you to do those sums in each of these 3 boxes here for the 3 different things I've listed. So an hour in the grounds of Chernobyl, a CT x-ray of your head, or eating a banana. I want you to see how many of those it would take to increase your health risk. Now, once you've done that, you've got this last job to do. We've got all these facts here about eating bananas. Bananas have a tiny amount of potassium in them. We know that the ionizing radiation dose from the potassium is about 0.1 microsieverts, like you did in this sum. We do know that ionizing can cause mutations which lead to cancer. We know that it takes 100,000 microsieverts to increase your risk. So I want you in this box here to write an explanation of whether you think eating 1 banana a day is risky. You know how much dose you get from it. You know the dose it takes to be unhealthy. And you know the risk that it can cause. So I want you to finish off by typing in this box here an explanation of whether you think eating 1 banana a day is risky. And a really good answer is going to have lots and lots of these science facts and numbers in it here. We've got lots and lots of information here about the risks. And the more information you use, the better your answer is. Now, once you've finished that sheet, the second half of your sheet, you're finished. Please make sure that you submit that finished worksheet back to me so I can have a look at it. And if you've got any questions or you're stuck on anything, please drop me a message in the assignment. Otherwise, that's the end of my video. And I am going to stop sharing my screen and I want to wish you all the best with that. Good luck.